So this is how many states we visited. I want to take a few more. I think I just put it in my TI actually.
Well.
I know, it's still talking to us. So L1, L2, and again, this is one of those things I want to make sure, and thank you guys also, every person that volunteered something today, Renee, John, Stacy, all you guys that talked about the assessment that you just took, you're hitting the nail on the head of what is wrong with American math education, just so you know. You're all hitting it directly on the head. Blindly plugging things into formulas we don't really understand, not being able to process something that seems too easy, right? I mean, I've often been quoted the statistic that 90% of the time your gut feeling is the right one. I don't know who the hell made that up, but anecdotally, it seems to make sense. I mean, how often when you change a guess, not just on an exam, but also in life, when you change your first gut feeling, are you wrong? And it seems to happen more than going the other way, right? It seems to happen more. Math education should reflect that, and that's what statistics tries to do. It tries to sync up your feelings, your intuitions with some kind of numerical computations. And you will get that over the next 7 weeks with me together, with us together for the next 7 weeks. You'll get that. I mean, whether you like it or not. Hopefully you like it, because it makes it more pleasant that way. But you are targeting exactly what's wrong with American math education. The difference between my son at 6, who loves to play with numbers, who loves to look for patterns, who loves to count, and a teenager who hates going to algebra class. Something happens in those, whatever, 8 years, 6, 7, 8 years. And the problem is systemic, and we're working on a fix, but from the top where I'm at, when I see the result of high school, it's kind of hard to fix it once I do my damnedest. F-bombs notwithstanding. We're going to keep trying. But nonetheless, it's a trickle-down kind of thing, I think, and we're working on it. We're working on a solution, one stat student at a time. All right, here
I'm in 111.
Here are our results. What's that?
I'm in 111 right now.
And I feel your pain, brother.
I go there before I compare.
I know, so you get good and worked up.
That's confusing.
So I'm like, where's my formula?
I know. Your formula's how you would. So here you go. Here's a bunch of data. Describe how many states you guys have been to. Describe. How many states have you been to on average? Boom, there's a question for you. On average, how many states you've been to? And you can take whatever average you want to use. I think we did this last time. I think we ended up doing this last time with
60,
together. Yes, remember doing this?
30,
So here's our data. As you scan the data really quickly, you might decide first to make a histogram of the data to see what it looks like. That's where I always like to start, by making a histogram. That's my personal favorite. I didn't make you do this on your exam just now.
Well, some people may have.
Right?
And that's okay. I just said I didn't make you do it. I'm just saying I didn't make you do a histogram. You can totally do it. Here we go. Stat plots. Stat plots. Let's turn them on. Turn a histogram on. It's a great idea too. Did you do it for the bags of chips?
I did most things.
That's okay. Or, now what was nice about the baby weights was you really didn't have to. You could actually see, if you turned it sideways, you could actually see the kind of hump in the bell curve. Although it's not really a hump, you need to see how humped it is. The bag of chips, I didn't even want you to do that. I just wanted you to strictly find the average and the median and the mode and finagle with them. It's totally cool. It's a great practice to get into, graphing every data set you can. Because that can tell you, as Christina just pointed out, should we even use an average? I don't know. Let's look. So let's turn it on, histogram L1, L2. Is it important to have L1 and L2?
Yes.
Because you have?
Both the frequency and the
Yeah, you got data and you got a frequency. Very, very important. Very, very important. You have to do both. I think some of you might have had errors on your exams with that too. You'll fix them. You'll fix them and you'll learn. You'll fix them and you'll learn. Okay, zoom stat. There it is. Finagle away if you want to. Finagle away if you want to. I'm going to finagle a little bit, just a smidge. 5 to 20, maybe we could go 5 to 30 by maybe 3s. That's what that looks like. That's not bad. I just changed, all I did there, friends, I'm sorry, I did that kind of quickly. I did a zoom stat real quick, get the bars up there. And I usually don't like that graph. I like to have a few more bars. So I changed X min to 5, X max to 30, and X scale to 3. And what that'll do is it'll lay down a different number of bars across. And here they are. Now, whether you looked at the previous graph or this one, would you call that bell curve data? It's a stretch to call that bell curve data. You've got these hump, you've got a hump over here, you've got a spike right here, and you've got a little bit of a hump spike over here. So if you were to draw a curve that kind of fit this data, it definitely would do something like have a couple undulations besides just the one on the bell. And you can mess around with it all you want. You can change the X scale to 2, regraph. The humps are still there, they're just kind of spread out in different ways. And even if you just did zoom stack, again, the humps are there. So this is why I like finagling. I like finagling because every once in a while, you can break it down to a graph that might look different than the other ones, but by looking at it a bunch of different ways, you can say, okay, on average, this thing does not look like a bell curve. Since it doesn't look like a bell curve, why would we even care about that? Why would we care? And let's make it more general. If the graph wasn't symmetric and unimodal, why would we care? We might not, we might consider not using standard deviation, Heidi, because the standard deviation is tied to the average, which might be, listen to you guys, which might be skewed because the data is not symmetric. Check it out. And you can check the statistics, by running one-var stats. This is why I don't want you using formulas, John. I want you to focus on the discussion we just had. It's not symmetric data. The average might be pulled too far to one way. How many times have we said that over the past couple of weeks, right? It seems like all the time. Of course, I'm fighting 16 years of American education in 2 weeks, so I'll keep doing it because I'm Italian and German and I'll fight. So, L1, L2, right? Just like we did with the graph. Yeah, L1, L2, this is what you need for the newborn baby weights, just in case for the rated X, and you will do it on the corrections, won't you? Yes. There we go. Now we got a bunch of stuff, we got a bunch of stats we can record here. On average, we've been to average number of states, we've been to, it's about 16-ish. So that means 16 states per student. So what do you think? Should we use the average? Does that do a pretty good job of describing what's going on?
No.
Honestly, I think it's a pretty terrible idea to talk about that because look, you've got one student that's been to 16 states. And then even near that one student, it takes a while to get out until we get into those humps. So leave it up there as a statistic, but realize that me personally, I wouldn't use it to describe what's going on. Is there a mode?
13, 28.
Oh, there's 2. That's right. There's a 13 and a 28. The modes of the number of states is 13 and 28. How do they do as describing what's going on in our data set? Great. Tell me why, Renee. I love it. Go, tell me. I like this. I like it better than the average for sure.
Because
Go.
it's different.
Oh, because it's different. That's good. So she's saying since the average sucks, and the mode's different than average, the mode's good. Now that doesn't mean there could be more than one way to suck. I mean, we could be off in all of our measures of center. Now, I like what she's saying though, because both of those numbers at least get us close to where the majority of the humps are. They're not at the center of those humps, but they're closer. So I'm with you there, sister. I'm with you there. Go ahead, Tiffany, you were going to say something?
It just looks more, it looks better to the eye than 16 does.
Sure, and if we do this, I'm going to real quick, let's change it back to 2, I think. So here's 5, 7, 9, 11. There's 13. Notice 13 kind of centers on the humps of this histogram. 28's over here, I believe. I think 28's right here, which centers on one of those spikes. So it kind of fits better than 16, which is going to be here.
Right.
So, I mean, as far as graphical goes, it does sit in the graph better. So I'm with you, Renee. I'm with you. I'm not saying that there's no right or wrong way. The average of the data is 16. The modes are 13 and 28. The median is what?
13.
Is it 13?
Yeah.
Thank you. The median is 13. You guys know where that is, right?
Yeah.
Right, down low. Good. What's the standard deviation? About 7? I'm going to put that up here with this guy. These are all in states. The units of all these are states. 7 states, plus or minus 7 states from 16, 13 states, 28 states. Okay? But the thing about statistics is, see, in a math class, you would be done right then. Here are the answers. A statistics class says, okay, is there a better way to talk about the data? Right? And that's what is making you guys uncomfortable right now, is that part.
Super like talking about it.
Good!
Just no tests.
Well, you see what you're like, on average, you guys don't vote for no tests. I'm hearing from 2 people out of 60 that I teach. We'll hear what the survey says at the end of the term when I do it again. That's what I'm saying. Don't be putting bias in my survey. Pisses me off. What I'd like you to do is scroll down where you found the median. Oops, second, enter, there we go. So you got your average, You got your sample standard deviation, you can ignore everything else, 23 data points, okay? I also like, Renee, the mode because it's 25% of your data. 6 people went to 13 or 28 states, and that's just about 25% of 23, so you've got a nice chunk of the data there too, which is also good. Although we don't talk about that a lot in this class, we will towards the end of it. Okay, so here's what I want to wrap up with today. What are those things right there? This. What is this? Danny, go.
I got it.
You got it.
It's all of the values you need to make a box plot.
That's 100% true. Good, good. Let's write that down.
So
These guys right here are called the 5-number summary. Okay. Let me back up again. Now you know what? No, we'll end with that. We'll end with that. 5-number summary. We might not get to the box plot. I don't want to rush to get the box plot in today because I do want to come back to our data, and I think to give it the proper amount of time, we'll do it on Monday. We'll see how this goes, though. The 5-number summary consists of 5 data values, only one of which we've really talked about a lot so far. Okay, only one of which. And that one that we've talked about, well, give me a warning, I'm not going to close. The minimum data value, which I think you guys can figure out. Q1, we'll come back to him. The median data value, which you already know something about. The Q3, which, and the maximum data value. Now, what this is, the minimum, you know what that is, it's the smallest. So for us, that means 5 states. That was the smallest, least number of states somebody had been to. It doesn't tell us how many have been to 5, it just tells us that the smallest one is 5. And you can see how that could be slightly disadvantageous. If, 23 people in the room have been to 5 states and one has been to 48, the min would still be 5. And it wouldn't tell you a whole lot. The max, conversely, is somewhat. This is for the same reason, Heidi, I think it was you actually, on the first days of class, I think, when I asked make up a measure of variation, I think it was you that said go high minus low and call it range. Remember that? Yeah. And that's a great measure because it tells you the spread of our data, but it doesn't talk about the inside data points and where they play from. That's what the other 3 do. The other 3, the median and the Q1 and Q3. Let's talk about him. Let's talk about him real quick. Our median is 13. What does that mean? Give it to me in words. We say the median of our data set is 13. What does it mean to have a median of 13? Stacy, go!
Middle point.
The middle point. Roxy, give me more. I love that.
The very center of all your values.
Good, good. Which center? I love center. Is it the balance point?
No, it's the center of the frequency.
The balance point would be the 16, right? And the problem is there are those heavy data points that force the average over to kind of balance that. So when you're saying center, what are you saying, Roxy? I love it.
Like if you were to go like this.
Mm-hmm. She's making the chop with the hands. Remember the chop with the hands? Somebody over here was either Patrick or Jared.
Center of the max and minimum?
It can be. It doesn't have to be, though. What you're assuming, what Patrick said is important. And we'll get into this more on Monday. It can be right between the max and the min, but it doesn't have to be. Check ours out. How far apart are these? 15.
15.
How far apart are these? You see, there's more spread on this side than this side. Ooh, I just said sides, Christina. What am I talking about, sides?
You were talking about in the box plot, but it's the one with the middle frequency. Like,
Good, good. How many people reported data in this study? 23. 23. 28 is the maximum number of states that the one person on top had been to, or 3 people on top had been to. So there are 23 people in order, and we're going to draw this out on Monday when we have a little more time. If you put all those numbers in a row, and you found the dead middle number, it would be the median. So if you line up those 23 people, and you say throw away the bottom 11, throw away the top 11, that throws away 22, boom, the 12th one in the middle is the median value. Danny, go.
The median divides the lower half and the upper half.
So, thank you, perfectly. The median divides the lower half of the data from the upper half. Now that's a lot of writing. I prefer not to do that every single time. So let's use a phrase we learned on Monday. Remember percentile? Remember percentile, remember max? How much does max weigh? Which percentile is the median? And Danny's already given us the answer, hasn't she? It's the 50th percentile. Because it does just this. It divides the lower half from the rest. That's what a percentile is. What percent are you bigger than? Well, the median is bigger than 50% of the data. Boom! This is the 50th percentile. Just to revisit this idea from Monday before you forget it all about till next Monday. But this way, at least I'll bring it slightly back to the front of your brain so it doesn't go as far back to Monday. We have a symbol for this because that's a lot of writing too. The symbol for it is a big P sub 50. Sub 50th percentile. This is fairly standard. Andrea said she's seen it before, and it's good. You probably have seen this in text. If you look at percentiles in textbooks or in research journals, you'll see big P sub 50. The implication is that it's the 50th percentile. Fair enough? Okay, now, friends, let's explore these guys now. Q1, Q3. Q1 in our data is 11. Can you figure out why Q1 in our data is 11? I'm going to make some marks over here that might help us figure this out. Our median's right here, right? This is the median.
So Q is, what's Q again? Quarter?
We haven't even, it stands for quartile.
Okay.
But that's not as important as what that number means for, but we'll come back to that, Tim. There's a reason why it's called quartile. There's a reason I said quintile to you last time, Danny. We'll come back to both of those things. That was fine.
The
Good.
median on both sides.
It's halfway between the minimum.
Did you hear what Tim and John just said? Of course I interrupted John as he was talking. Tim, say what you said again.
Oh, the median between the median and the max or whatever. Like 3/4.
You said that it's exactly what it is.
3/4 mark.
It's exactly what it is. John, go.
So the Q1 is the halfway between the minimum and the median, and then Q3 halfway between the median and the maximum.
That's exactly what it is.
Say that one more time.
According to frequency. Good. Good. Let's write it. Let's write it, shall we? And we'll come back to your question, Renee. It all has to be according to frequency, yes. So Q1 is going to be, it divides the, I'm going to rephrase it a little bit, John, if it's okay. It divides the lower half of the data into halves, which would technically be called quarters. Because if you're cutting a half in half, you're then getting 2/4, right? Hold that thought, Heidi. Hold that thought, my friend. Let's see if we can make sense with that concretely with our numbers over here, okay? So, remember, the median was 3. That puts 11 data points underneath of it, correct? So halfway between 11, we're going to cut the bottom 5 off and the top 5 off and use the middle 1. Does that make sense? We're going to do this with I'm going to do it with a box plot on Monday, and we'll revisit this idea. But if you cut off the bottom 5, 1, 2, 3, 4, 5, throw those away. I'm doing that by frequency to answer your question, which is a very good one. See, 1, 2, 3, 4, 5, they go away. Count the next one, which happens to be that 11 right there. That's why that guy's your Q1. That next data point becomes Q1. So in other words, there are 5 data points below it, and there are 5 data points here. Now, Tiffany's frowning because this doesn't look like 5, does it? Count the frequencies, 2, 2, 2, 2, 3, 3, 3. There are 7 data points represent, I know there's only 11, 12, and 13, but there are 7 of them, right? So one of those 11s is the next data point, then you've got 2 12s and 2 13s, there's the other 5 you're throwing away. You've got to get used to those frequencies. Those frequencies mean something. See how spread out these are compared to this? That's variability. More variable, less variable. Hopefully that makes sense.
Yeah.
Good,
Less
good.
variable.
Less variable, tighter together. More variable, more spread out. Does that make sense?
Yes.
Good, fair, yes. Okay, good. So our Q1, oh, let's say it a different way. What percentile is that?
25.
Has to be, doesn't it? It's the 25th percentile. It's also called the first quartile. This is what we mentioned quintiles in class last time. Your TI doesn't do those for you, and that's okay. Let's figure out what quartiles are first. It's the first quartile. Fair enough? What do you think Q3 is? It's the third quartile, which would be the what? Yes! The 75th percentile. I'm going to swing the camera out and pick up these notes and we're done. In words, using John's awesome language before, or Tim's for that matter, using Tim's, the third quartile would be the median of the upper half, wouldn't it? Be the median of the upper half, or it would be halfway between the median and the max value. Now, according to our TI, that value is at 23. Can you see why it's at 23?
Because the frequencies.
Yes! Look at all these ones! See all those ones? That's the 5 below the upper quartile. And then there's 1, 2, 3, 4, and one of those bad boys are the 5 above. You keep the one in the middle. Look at the variability here. Way more variable between here. Look at the range. 13 to 22 or 23 compared to 11 to 13. Variability. Now, Danny, what you have already pointed out to us is that you mentioned a box plot, which we'll get to on Monday. You can almost see it here. You're almost looking at what's called a box plot at that. We'll get to that on Monday. I promise you first thing. One last question. What would the median be? Say it a different way. It's 50th percentile. Could we call it something else?
Middle between
Second quartile.
Second quartile. It's Q2. Nobody actually calls it that. They call it the median, because the median's a more common language term. But this goes back to what Patrick said. Does Q2 have to fall exactly between Q1 and Q3? Not unless the data is perfectly symmetric. Then it does, but not necessarily. Making sense?
Yep.
This is called relative position. It's okay if it's not. It's okay if it's not. I don't expect it to make perfect sense right now. This is just kind of a new way of looking at data. Why is it powerful? Because it doesn't care about bias because of outliers. You can say that 25% of people in this class have been to fewer than 11 states. Half of them have been to fewer than 13. 25% have been to more than 23. And this kind of stuff happens all the time in the news. We're going to pick that apart starting next week too. Okie doke? All right. No homework except to finish your out-of-class exam. All right? That and realize the beautiful journey we are on together. But I'll keep forcing that down your throat whether you like it or not. All righty? Have a good weekend. Thank you. Try. Okay. Get back on Wednesday. Get back on Monday. I promise you that.
I'm not going to be here on Monday.
Well, you'll get it back on Wednesday then, and you'll turn it in the following Monday. Oh, that... I was supposed to get that stuff back to you guys. I actually have some stuff. Oh, but I did it back. Yeah, you didn't get it because you weren't here, Stacy. It's here right now. Katie, you still here? I got some stuff for you here. Taylor, did you leave already? You did not. I got random stuff mixed in here. That's for you. Cindy, I got your project here.
Thank you.
You are welcome, Andrea. Renee, you here too?
Yep.
I got a quiz for some. Oh, that's because I had to add points to your guys. That's why I'm giving this back to you now. John, your quiz is here. You already left.
Yeah.
Abby.
Or wait, here we go. Oh, I got
Here, she was here.
this one's for the camera.
I still left.
Tim is here, if he's still here. Here, grab this. Oh, yes, thank you. You can.
I still left 2 legs that we were
You did. Sydney.
Oh, yeah.
What's up? Oh,
That's gonna scare Sean. You're gonna take that home and go,
Oh my gosh.
You guys are kidding this.
No. John. Tim took off, I think. Joe, I don't know yet. Heidi, you still here? I got some quizzes for you. There you go, Abby. Stacy. Boom. Boom. Jared, you still here? Yep. There you go, sir. Joe, I don't know. Still. Roxy, you still here? Go. In front of me. There you go.
You're recording
Stacy.
this.
Jared.